My name is Hardeep Patel from PDU. I am a team leader of Team 1 of Division 2. So our team project is about CPU scheduling. So now let's have a quick look of our website. So on the first landing page, it's written that what is CPU scheduling? CPU scheduling is a process of determining which process will own CPU for execution while another process is on hold. The main task of CPU scheduling is to make sure that whenever the CPU remains idle, the OS at least select one of the processes available in the ready queue for execution. So we have also added a guided tool which acts as an X factor for our project and which stands out from the other websites made by the various teams. So now I hand it over to Om to explain more about the guided tour and rest of the site.
Yes, I am Om. So as Hardeep previously explained, we have added a guided tour to our website to make a standard from all the other websites. The guided tour will help us step by step to go over the website, and if a first time user comes into the website, he or she can easily go to the website and understand what it is all about. So the first thing you can do to activate the guided tour is press the button right here which says guided tour. After that, it gives a little prompt and it tells you press next to begin. So let us press next, and this is where it takes us first. This is our home button, and if on any point of time you want to return to the home page, you can just simply press this button and you'll be back on the home page. Okay, let's go next. This, as my dear friend Hardeep already explained, this is a prompt which informs about CPU scheduling, which is a critical feature for operating systems to function properly, right? CPU scheduling is basically aligning or giving or placing processes in a queue so that each process gets a turn at completing it. Moreover, there is no deadlocks or errors in the CPU while doing the functions that is necessary for it. Let's see this. So this is the area where we have shown or showcased all the 4 algorithms that we have implemented as part of our project. The 4 algorithms are first come, first serve, shortest remaining time first, shortest job first, and longest job first. So let us look at each and every one of them algorithms one by one. So while you press next in the guided tour, it basically takes us through all the 4 algorithms, and for a first time user, it gives them a brief description of what they are about. And if you want to read more about them, you can go to the more info section, which we'll be doing in just a few seconds. So when a first time user comes, he or she will be guided through all 4 algorithms and basic definitions of them. Like the FCFS is an operating system scheduling algorithm that automatically executes queued requests and processes in order of their arrival. That is, as the name suggests, the ones that come first are the ones that are served first. When we go next, it is shortest remaining time first, which is SJF algorithm with preemption. If you don't understand it right now, don't worry, we'll be looking at it in a little more detail while we'll be going over each and every one of them. The guide tool takes us next to the SJF algorithm, which is shortest job next. So like whichever process has the shortest burst time will be put into the service. The next is longest job first, which is a non-preemptive way in which exactly opposite of shortest job first, and whichever process has the longest remaining burst time will be served first. Pressing next, that is the end of our guided tool. If in any point of time again you want to call the guided tool back, you can press this button right here and call the guided tool back. This is our team section, and these are the people that made this. Okay then. Okay. So now let's look at each and every algorithm. First is first come first serve algorithm. When you hover over the prompt, you can see this message which gives you a brief description of what the algorithm is. As I explained previously, first come first serve, as the name suggests, whichever process comes first in the queue gets served first. That is basically the core of how the algorithm works. If you want to understand it more, we can go to the read more page here, which gives us the description of the algorithm, what are its advantages, its disadvantages, and the summary, its characteristics, etc., etc. So now let's after you read it the prompt, let's go and evaluate the first come first serve algorithm to see put values and check what it results it gives and get a better understanding of the algorithm. So we'll click on the evaluate button here. We'll get this interface basically, which have these are our values. The first time is the time the process takes to complete. The arrival time is the time at which your process arrives. As a safety measure, you can't go beyond below 0. No matter how hard you try, you can't. That's a JavaScript we have added to prevent it from. That's a HTML we have added to prevent it from going below 0. Okay, all right. Because arrival time cannot be negative. Now let's see what will happen when we click compute. Obviously, we will get the output of the algorithm or a walkthrough of how it will work. So let's try and understand this. Okay, so let's see. At time 0, we have algorithm or say process 0. Process 0 arrives at time 0, and it works for 2 seconds because that's its burst time. At 1 second, we also get a process 1. V1 enters at time 1 second. So P2's arrival time is 1, that is, it is already waiting in the ready queue. At 4, number of processes that have arrived is 3, including 4 and 5. P0's arrival time is 6, that is, while P4's arrival time is 6, that is, while P3 is getting completed, it is already in the waiting ready queue. So at last, P3 gets completed after all the other processes have been completed. Time duration of 4 to 5 seconds is thus wasted because there was no process in the ready queue, and both the processes will have been completed by 4 seconds or for quantum. The completion time of each process is thus derived and is mentioned here. The turnaround time, that is the time taken between completion of a process and the arrival, is also mentioned here. So basically 2 minus 0 for process 0, so 2, 4 minus 1 for process 2, that is 3, and so on. The waiting time, that is the turnaround time minus the burst time, has been mentioned here. Like for process 0 it is 2 minus 2, that is 0. For process 2 it is, or process 1 in our case, it is 3 minus 2, that is 1, and so on. So that was our first come first serve algorithm. Now let's look at another algorithm, that is shortest job first. Okay, so now let's look at shortest job first. Shortest job first is an algorithm which implements the process in such a way that the process with the least amount of burst time gets executed before other processes. As the name suggests, it gives priority to the process with the shortest amount of burst time. As the criteria for differentiating in this case is the burst time. The mode of this algorithm execution is non-preemptive. It does not let anybody or any process get a preemption on other processes. So now let's do a trial of this algorithm like the before said algorithm. We input some values and understand the computation to get a better understanding of the algorithm. So let's take 4 processes, that is 4 number of rows will have to be added. Process 0, 1, 2 and 3 are the 4 processes added here. Now let's put in some arrival time and burst time in here. So let's click compute. Great. So now when we look at this algorithm, we can see that from the time duration of the algorithm that arrives first before any other algorithm is 1 second or 1 quantum of time. So between the process of 0 to 1 there is no algorithm in there, and that's why the process is named waste, or the time duration is labeled waste. Or process 2 has the shortest time and therefore it is awarded the CPU for functioning. That is how the algorithm executes. That was all about shortest job first. Now let's look at our next algorithm, which will be shortest job first with preemption. It is called shortest remaining time first. Okay, now let's look at shortest remaining time first algorithm. As the name suggests, shortest remaining time first algorithms gives priority to the process which has the remaining amount of time left, shortest amount of remaining time left. It is basically the shortest job first algorithm with preemption, wherein one process can jump into the queue and take the control over the process or the CPU or the resources while the process is still performing its task. Now let's look at the algorithm. Okay, like putting in some random values, trying to understand that and improving our understanding of shortest remaining time first. Okay, so let's again put in 4 processes. Process 0, 1, 2, 3, 4. Sorry, 0, 1, 2 and 3. Let's put these 4 processes to use. I will put in 4 for the number of rows, for the number of processes that I want. I click add rows, and here I have 4 processes or 4 spaces for 4 processes again. Now let's input some arrival time and burst time values. Okay, let's click compute. As we see, when we click compute at time 0 seconds, there is only one process, that is P0. P0 will be executed till at least 1 second or 1 quantum of time before another process, that is P1 enters. And that is what happens. Now the completion time and the turnaround time, as mentioned earlier, completion time is the time taken by the algorithm to complete, as the turnaround time is the time taken between completion of the algorithm and the arrival time of the algorithm. The average turnaround time is calculated and displayed in the box here below. That was all for shortest remaining time first algorithm. Okay. Longest job first is a final algorithm which we have implemented. As the name suggests, it is longest job gets the first control over the resources. It is opposite of shortest job first, which gives priority to shortest jobs. Longest job first is also very easy to understand because it simply gives away the time or the resources, the process which has the highest burst time at any given period of time. Now let's look and try to understand longest job first by evaluating it using our simulation. We'll again put in some random values, try to compute the result, and try to understand the result to get a better understanding of the algorithm. Now let's enter some random 4 processes so we can understand the algorithm better. Okay, so let's take into consideration 4 sample processes. We'll evaluate it and try to understand longest job first better. So I'll enter here number 4 to take into consideration 4 processes and add 4 rows respectively. So I'll click the add rows button. Let's take in some sample values. 8 here. Okay, let's see. When I click, what happens when I click the compute button? As you can see, at time 0 to 1, there is no process in the queue, so that time will be wasted, and hence waste is written here. At time is equal to 1, only process 0 will arrive, so no need to think, simply process 0 will run, for burst time is equal to 2. Now at time is equal to 3, process 1 and process 2 both have entered the queue, but process 2 having more or longest burst time will run for 6 seconds, that is from 3 to 9. At 9, all the processes must have arrived, but process 3 or P3 has the highest burst time, and hence it will run from 9 plus 8, that is still 17 seconds. After that, the only remaining process we have in the queue is process 1, which will run for 4 more seconds, that is still 21. By the end of 21 seconds, all our processes would have run in the queue. Let's see what is the completion time of each of the following algorithms. The completion time, as we can see, of process 0 is 3, of process 2 is at 20, process 1 is at 21 seconds and it gets executed last. Similarly, 9 ends 20 for process 2 and 3. The turnaround time, as said before, is the subtraction of arrival time from completion time, that is the difference between, or the gap, or the period between completion time and arrival time. So it will be 3 minus 1 for process 0, that is 2, 21 minus 2, that is 19 seconds and 19 quantums of time for process 1 and respectively. The waiting time of the processes is equal to turnaround time minus the arrival. The waiting time of the following processes can be calculated respectively by subtracting burst time from the turnaround time. 5. That was all about the longest of first algorithms. Let's return to our home page. And again, folks, thank you very much for being part of our journey. This was us. You can go check us out on our team section. Our team includes Hardeep Patel, Baldaniya, myself, Aum Davda, Yash Jobanputara, Patel, and Devraj Jhala. It wouldn't have been possible to make this project without the contribution and hard work of each and every one of them. Lastly, we would like to thank Rutvij sir for giving us this opportunity and this project to explore CPU scheduling better, and which has also made us very equipped with web-based technologies. Signing off. Thank you for watching our video. God bless you all. Bye.